In every blast furnace, there is an invisible but critical line, the 1150 isotherms. Knowing exactly where the line is inside your hearth can mean the difference between a long campaign and early expensive repair. Today I will show you a simple, accurate three-step method that any operator can perform in seconds using just two thermocouple reading. The 1150 degree centigrade line marks the boundary where the protective carbon lining starts to wear rapidly. If this line moves too close to the shell, you are in danger. Fortunately, you do not need to guess. You can calculate its exact position every shift. Most modern hearths have two thermocouples embedded in the carbon, that is TC1. But many furnaces, bigger furnaces, also have a three closer to the shell. Typically reading around 150 degrees centigrade TC2 deeper towards the hearth, reading slightly higher in this example 160 degree. The distance between them is fixed, usually 50 mm. Our target is to locate where the temperature reaches exactly 1150. Guessing is dangerous and unnecessary also. With the three-step formula you can about to learn, you will always know the precise distance. And many times we do also come across a just perception about okay, it's showing this much temperature, so what should be the how much wear must be there. So for such type of a speculation, finding a thumb rule short of thickness, this calculation also suit well. So inside the heart, temperature rises steadily from cool shell towards the hot metal. The 1150 isotherm is simply the point along that gradient where temperature hits 1150. So let's start with the actual reading TC1 150 degrees centigrade and TC2 160 degrees centigrade, and distance between them, as I have already mentioned earlier, 50 mm. Target isotherm is 1150 degrees centigrade, and in our earlier presentation we do also see that how the 1150 is scientifically proven from iron carbon diagram is the uh, concrete interface which separate liquidus and solidus phases. So we know apply a straightforward linear extrapolation perfectly valid because the temperature gradient in the carbon lining is essentially linear, what we assume over all our calculation. And in this range also assumption is taken that it's linear. Now coming to the step 1, as it is shown, we had calculated the temperature gradient, that is if TC2 minus TC1, as it is mentioned, TC2 160 degree minus 150 degree, which is 10 degree, is the difference, and distance is 50 mm. Therefore gradient we have to find out 10 degrees centigrade divided by 50 mm, which is equal to zero point 0.2 degrees centigrade per millimeter. This is a gradient, and with respect to this gradient we going to extrapolate the 1150 degrees centigrade. So the temperature rises zero point 0.2 degrees centigrade for every millimeter we move deeper into the hearth. Now coming to the step 2, which determine how many degrees will still separate us from 1150 degrees centigrade. So current temperature of TC2 as mentioned 160 degrees centigrade, target is 1150 now. Now temperature gap is 1150, which is the Isotherm temperature minus 160 TC2 temperature. The difference is 990 degrees centigrade. And now the step 3, which is going to give us that magical number. Convert that temperature gap into distance. Distance beyond TC2 is equal to temperature gap divided by gradient, which equals 990 degrees centigrade divided by zero point 0.2 degrees centigrade per mm is the gradient. So this gives 4950 mm, that is 4.95 meters. So this is a sort of a exemplary calculation which just make operators understand that how the thickness is getting measured. So, so in conclusion, we can say that the 1150 isotherm is located 4.95 meters beyond your inner thermocouple TC2. From the cell, it is known distance to TC2 plus 4.95 meter. What does this number mean in practice? Above approximately 4 to 5 meter, healthy thick carbon lining, excellent condition. When the distance shrink to 1 to 2 meter, warning zone starts planning corrective action. Below 0.5 meter, critical. The isotherm is dangerously close to shell. Here is one line formula you can use every day. Distance is equal to 1150 degree centigrade in mm is equal to 1150 minus TC2 divided by TC2 minus TC1 divided by 50. Just plug in your this latest TC1 and TC2 reading and you instantly having the position. Finally, remember, it's not only the absolute position that matters, it is the trend. Track how this distance changes week by week. A steady shrinking distance is the earliest and most reliable warning that your hearth is wearing.